Okay, before I look at this, now I'm not dealing with the apothem in there, right? Don't have an apothem this time. I just have one measurement outside. Now the polygons are still going to be regular. Polygons are still going to be regular. However, when I only know one side and I have no more information, I'm going to have to rely on special right triangles. Remember the 45, 45, 90 and the 30, 60, 90. Let me remind you guys of those figures. So we had a 45, 45, 90. And that is in reference of the angles. 45, 45, 90. Now remember that the two sides that make the 90-degree corner were equal. So if this is X, then this is X, right? I'm using a letter, just it could be a number. And remember another thing. Whenever I needed to go from one side to the hypotenuse, I multiply this by square root of 2. And if I needed to go backwards from the hypotenuse to the side, I divide it by square root of 2. Right? We saw those, so I'm just reminding you guys of what we saw. It was nothing new. Another triangle that we saw was the 30, 60, 90. So this is 30 degrees, this is 60 degrees, and this is 90. Let me call the small side X. For me to go from the small side to the hypotenuse, I multiply by 2. Not radical 2, this case is 2. And obviously, if I'm going from the hypotenuse to the small side, I divide by 2. Now, if I'm going from the small side to the medium side, I multiply by square root of 3. And if I'm going backwards, I divide by square root of 3. Okay, so make sure you guys remember those. Now, you guys might be wondering, Leonzo, why are you doing this? Because we're going to use those, okay? So remember your 45, 45, 90. Remember your 30, 60, 90. Now, having that said, let me take a look at question number 19. Now, I'm going to say the centered. The centered is about here. Center of the polygon. To begin with, let me connect my center to every corner. So basically all my radii. And I broke this into triangles. Not only that, but let me cut each of these triangles in half. I'm gonna go here, 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 and here. And I'm gonna focus on one of my triangles, this one. Interesting, this is gonna be 90 degrees. Now, how many triangles do I have all together? Let's count. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 triangles. Interesting, let me do in blue. Interesting, if you notice, there's a circle here, right? Remember how a circle is 360 degrees? So what's 360 divided by 12? Because I'm going to be breaking this into 12 different pieces. So I'm going to go 360, which is the whole circle, divided by 12. That's 30, right? Maybe. So that means that this angle here is 30. Let me zoom out here more. So here's 30, here's 90, here's 60. And this side right here, I'm going to say it's 11 radical 3 over 3. Like, wait, what happened? 11 radical 3 over 3? Yeah, because notice how it is half of this, right? So when I say half, I cut the number on top by half. That's what I did. Okay, remember the 30, 60, 90? If I wanted to go from here, this is the small side, to the medium side, don't I multiply by radical 3? So let me do it here at the side. 11 times radical 3 times radical 3 over 3. See how I multiply by radical 3? I know that's 11 times 3 over 3. Because remember, square root of 3 times square root of 3 is square root of 9, but the square root of 9 is 3. I can multiply the top 11 times 3 and then divide it by 3, or I could just cancel these 3's and it gives me 11. So this measurement is 11. So if I wanted to know the area of the red triangle, what do I do? Well, Mr. Leonzo, you will do a triangle here, a fraction here, I mean, and you will multiply the two numbers that make the 90-degree angle. I used the idea of special right triangles to be able to find a second side. Now that I know the two sides that make the 90-degree angle, I can do the area of that triangle. I'm gonna go 11 times 11 radical 3 over 3, and all of this divided by 2. You guys see that? I know it looks ugly, but that's basically what we're gonna have to type in. And that gives me the area of the triangle. Now my result, I'm gonna multiply this by 12. Because how many triangles do I have altogether? 12 of them, right? So again, I'm multiplying the two measurements that make the 90-degree angle and divide it by 2. And the result, I'm gonna multiply by 12. Okay. Let me grab my calculator. Okay, so I have to go 11 times. But then I'm like, oh, then I had another fraction, right? So let me do another fraction. And I remember my fraction was 11 square root of 3 over 3. See, is that what I had? Divide this by 2, get out of the fraction, times 12. Let me bring you guys up. Let me see. Is this what I had on my calculator? Let me write this a little bit better. One of my sides is 11. Then I am multiplying this by 11 radical 3 over 3. So yes, is that what I have? You guys see that? Okay. Now I have to round it to one decimal place, right? So 419.2. The 5 is big enough. So 419.2. Okay, let's do another one. I'm gonna say the centered, number 20, it's about here. I connect it to each of my corners. And then each of my triangles, I cut it in half. There, there, there. And I'm gonna be using this triangle here. Interesting, this is 90 degrees there. Now, how many triangles do I have altogether? I have 6 of them, right? When I say 6 of them is, imagine your circle right here in the center. You're breaking it into 6 equal parts. The whole circle is 360. Break it into 6 equal parts. That means this is gonna be 60. This is 90. So this is 30. I have another 30, 60, 90 triangle. I know this measurement is 8 radical 6. Now, for me to find, this is the medium side. So for me to find the small side, then I go 8 radical 6 divided by radical 3. One thing I remembered is I can simplify my fraction as there's that 8. My radicals, I can see this as radicals, but I simplify 6 over 3, divide each number by 3, gives me 2 over 1. Interesting is that the square root of 1 is 1, so stops being a fraction. Any number over 1 stops being a fraction. So this is going to be 8 radical 2. Okay, so looking at the two numbers that make the 90-degree angle, for the red triangle, I will say 8 radical 2 times 8 radical 6, divide this by 2. It's fine. I'm going to type it on my calculator, so I'm going to be fine. So 8 radical 2 times 8 radical 6, all of this divided by 2. And then my result, I'm going to multiply this by 6 because there are 6 triangles altogether. So let's see. Let me clear this out. Let me do my fraction. So I have 8 square root of 2. Don't use the square root with the n. Okay, 8 square root of 2. Let me click outside of the radical times 8 square root of 6. At the bottom, I have a 2. I click to the side and I multiply this by 6. And I have to round my answer to 1 decimal place. Make sure you write on a piece of paper what you're gonna type before you type it. Okay, that's gonna help you out. Okay, so now here to have 665.1. So let me come back to my work here. And I say my answer is 665.1. Okay, let's take a look at number 21. Have my center there. Let me connect these to my corners. So all my radii. And each of my triangles, let me cut this in half. Because I'm going to the centered. Now I know in the center there's a circle, right? And that's 360. Seems like I'm breaking it into 12 equal parts. 360 divided by 12 is 30. Okay, so let me look at the triangle I'm gonna be focusing on. I know this is 30, this is 60, and this is 90. And I know this side right here, it is 4 radical 3. So I cut my 8, I cut it in half. Don't cut the radical, cut the number outside. So 4 radical 3. Okay. And I'm gonna say this other side right here, it is 12. Okay, you might be wondering, where do you get the 12 from? Okay, let me show you. The small side was 4 radical 3. To get the medium side, I had to multiply this by radical 3. So that basically gives me 4 times 3. Because radical 3 times radical 3 is 3. Now 4 times 3 is 12. So that's how I came out with this side is 12. So let's see. Just my triangle, I will go 12 times 4 radical 3 all divided by 2. That gives me that one triangle. Then my result, I'm going to multiply this by 12 because there's 12 triangles. So now that I know what I'm going to type, let me go to my calculator here. So I got 12 times 4, square root of 3. All is divided by 2, and then times 12. And it gives me 498.8. Beautiful. Let's take a look at number 22. I'm going to do my centered. Cut it to each of my corners. And each of my corners, each of my triangles, I cut it in half. And I'm going to be focusing on this triangle. And I'm going to say this side out here, it is 5 radical 3. I remember that the first thing I also do is I think there's a circle here, and that circle's 360. I count how many triangles I have altogether. There's 12 of them. So 360 divided by 12 is 30. So that means this angle right here is 30. This angle is 90. So this angle is 60. 5 radical 3 is the small side. So I want to say this other side right here, it is 15. How did I get 15? Well, I had 5 radical 3. Multiply this by radical 3. So it gives me 5 times 3, which is 15. Okay, so my triangle, I'm going to go 15 times 5 radical 3. All of this divided by 2. Once I get the area of that triangle, I'm going to multiply that by 12. And get 15 times 5 radical 3. And then, but I'm going to have a 2. Let me click outside of the fraction. Times 12. And it says 779.4. So my answer will be 779.4. Make sure you remembered how to do special right triangles.